All right, here we go. Let's go through this question now. All right, there's our possible answers. We got 31,720, 50,720, 175,018 meters cubed. What are we trying to do? We're trying to find the volume of this compound shape where we have a cylinder which has been removed out of it. The diameter of the cylinder is 20 meters, and we've got all of these other numbers, which we're then going to use firstly to find the lengths of the missing side. So we're going to find the missing side length, that side, and that side length over there. So let's go ahead and see if we can do that first. Looking at the vertical length, I can see that's 10, 5, and 15, which will make up that entire length. And 10 plus 5 is 15 plus 15 is 30. So this entire length is going to be 30 meters on this side. Horizontally, I've got from here till here, I've got, firstly, if I look at this length is 20. So this length is also 20, which means that that length is 20, right? And if this is 20 and that's 60, that means that this length is 40 because together they will add up to 60. And you see that length is the same over there. So this is going to be 40 over here. That's 40 in length. And if I move all of these numbers all the way up till the top, I can position them carefully like that. I've got 20, I've got 20, and I've got 40, which means that the total length at the top is going to be 80. All right, let me just remove these so you can see it clearly. There we go. So the total length at the top is taking into account, remember, if you can see this 20 is coming straight from this part over here. So this length from there to there is there. Can you see that? That's 20. That's the other 20 because that adds up to 40. If I go all the way down, if I take away 20, I'm left with 20. And if I take away 20 from the bottom, I'm left with 40, and that comes to 40 at the top. So if you get that, excellent. So this adds up. 20 plus 20 is 40 plus 40 is 80. So this total length at the top is 80 meters, and that's where we start from. We're going to calculate the volume of this compound shape. We're going to take the volume of the entire prism. All right, so volume of the entire prism. And we're going to subtract the volume of the cylinder. All right, volume of the entire prism minus the volume of the cylinder. Now the volume of the entire prism is made up of three different parts. We're going to calculate each part separately. So I'm going to highlight it over here. So that's the first part there. There's the second part there, roughly, right? And this is the third part over here. So those are the three parts that I want to calculate the volume of. This one's going to be 80 times 10, right? So this area is what I need. And I have to calculate that cross-sectional area first and then multiply it by my depth. And don't forget, this is my depth for both the cylinder and the prism. Will both have a depth of 20 meters. The volume of any cylinder, let me just write it here again, of any prism is always, which is also a cylinder, is given by area of cross-section multiplied by depth. All right, so that's the volume of any prism, and that's how we're going to calculate that using that formula, and we're going to calculate that using that formula again. Okay, all right, so I'm going to try and put it all together in one go. Let's see how it goes. We had area. We have area over here, which is going to be equal to 80 times 10, which is 800 meters squared. Then we've got this pink area over here, which is going to be also 5 times this length. And we said this length, remember, this is 20, this is 40 from there to there. So this area over here will be a total of 5 times 40, right? So that'll be 5 times 40, which is going to be 200. 200 meters squared. And at the bottom here, I've got area is equal to 60 times 15. 60 multiplied by 15 comes to 900 meters squared. And that's the area there. Um, so now we're just going to add it up, right? So we add it all up. 900 plus 800 plus 200. All right, that's what we're looking at. 900 plus 800 plus 200. So let's get rid of all of that. We got 900 plus 800 plus 200. That's the area, the cross-sectional area. Remember that volume is equal to area times depth. I'm going to just put it small now, 8 in a small form. Composite area times depth. And that number now is this over here. So that's 1,900. Don't forget the depth is 20 meters straight from there. So that's going to be 20 meters over there. So we'd multiply that by 20. Then we want to minus the volume of the cylinder. It's going to be pi times radius squared times by depth. All right, pi times radius squared times height, you can call it. In this case, the height is the depth. So that's 1,900 times 20. And I want to subtract pi, which is 3.14. My radius, by the way, is equal to 10 meters. So we put 10 in there. Don't forget to square it on your calculator. And the depth, remember, D is still 20. It's still 20 in depth over there. Okay, 1,900, here we go, times by 20. So the volume of the entire shape comes to 38,000. The volume of the entire shape comes to 38,000. And the volume of the cylinder will come to 6,280. So we have 38,000 minus 6,280, which is 31,720. 31,720 meters cubed. And that looks like the first solution that we had over there. So well done if you got that. We've just calculated the volume of the cylinder and the volume of the entire prism, and we subtracted the cylinder out of it, giving us the final answer there, which is 31,720. And that's it for that one there.